Welcome back to my channel. I'm Brian Kapicki, and I'm continuing this series, Master Databricks and Open Source Apache Spark. And this is lesson 29, PySpark. We'll be talking about how to write efficient and high performance Python functions that will run over your cluster leveraging Apache Arrow by using the Pandas Function Api. So let's jump in. In this video, we're jumping right into code. I want to show you how this works. I've covered the conceptual background in my prior videos, so please go back and look at those if you need to. And as always, I'm going to give you, of course, the sample code, and you can go in. I'll put a link in the description so you can get this notebook and run it for yourself. However, it is an as-is delivery for demo purposes only, so run and use at your own risk. Always test things before you use them, especially in a production situation. Now, we're going to be talking about coding custom functions you need to do, but you need them to perform at scale. In other words, running in parallel over the nodes in your cluster. You want to make sure they perform well, and you want to leverage Apache Arrow, which ensures that will happen. Apache Arrow magically replaces the way memory stores things so that it's compatible across all of the services you're using in Spark, which is extremely helpful for speeding things up. So the type of functions we're going to be looking at here, and this is again the Pandas Function Api as opposed to the Pandas User-Defined Functions, UDF, way of doing things. The difference here is these are completely new. The Pandas UDF that I talked about in the prior videos was really a recoding, a reformatting of the way you would code in the past. But this is completely new, where you can get new functionality. And the three types we're going to look at are group map, map, and cogroup map. You can see them here listed. Few things I want to point out, as I mentioned, is leveraging Apache Arrow, which is an open source project. Now, an odd thing about this may occur to you when you see the code is we're not using Python type hints as we had previously. Now, the documentation still kind of warns you that this is an experimental API, which is a little strange to me in a way because it is in a standard release and it has been around a while. So I believe it's pretty stable, etc. But I thought it was worth pointing that out. Each Pandas data frame size can be controlled by a configuration setting in Spark called spark.sql.execution.arrow.max records per batch. Long-winded way of saying you can change the number of records that will go to your nodes in each batch. And that's really important because, as you'll see when we do our grouping, it's going to send each group to each node. And if you have a particularly large set of rows going, it will send the entire set. So you could overload your node, basically try to put too much in the node and not have enough space to do that. I have a bunch of cells at the top of this notebook I've skipped over completely. We're starting at code cell 10, but I left them there because there are things I've demoed in previous videos that show you how to make sure that you have Apache Arrow installed, that you have PyArrow working, etc., etc. So feel free to run through those if you need to when you run this notebook and make sure you have things set up correctly. To run this code, you will need the database we created at the beginning of this series called AW Project, because we're going to be pulling data from Fact Internet Sales as well as the customer, DIM customer. So you need to make sure you have that data available. I will put a link in the description so you can get to the video that walks you through how to do that. You're only going to need 2 tables, so if you don't want to build everything out, you don't have to. So we're using, as I mentioned, AW Project. We're going to be pulling in customer key and sales amount from Fact Internet Sales. We're going to limit this just to 15,000 so that we can kind of make things run a little quicker for us. And I'm appending the drop NA to get rid of any rows that have NA values in them. You can see we have our customer key, which is an integer, and a sales amount, which is a double, which means it can hold decimal values. You can do a quick display to see what is in there. You can see this is an integer, and the customer key uniquely identifies each customer related to the sale. And then we have our sales amounts here, which are obviously dollar amounts or decimal. So as I mentioned, we're going to start with the group map function. The thing with the group map is the real goal of this is to do what's called the split, apply, combine pattern, which I believe was really introduced in R programming, where you split up your data and put it into groups, apply some function over it, and then combine it back together. Now, the steps we're going to have to take to do that, which is kind of implicit as you see in the code, split the data into groups using the data frame group by method, apply the function to each group, and notice the input and output of the function are going to both be Pandas data frames. The input data contains all the rows and columns for each group, and we're going to combine the results back into our data frame to be returned. Now I kind of follow a pattern in this. The documentation on the Pandas Function API is extremely sparse. The only examples I could find were really on the Apache Spark site, and they're really poor examples. I think they give you a sense of it, but they don't really give you any sense of why or how you would use these in most cases. So I'm going to start with their example, and then I'm going to try to give a more complex example, and I even do some experimentation in here that I'm not sure is approved, but I wanted to see like what you might be able to do with it, because I also get comments asking, can I do this and this, and I wanted to try myself some of those things. So we're going to start off by creating a data frame called df using the Spark data frame method. We're going to insert these values, and the two columns we're going to be creating are ID and V for value. So this would be the ID and then the value, etc., these rows. Then we're going to create our function, right? Def. We're going to say subtract mean. The idea of this function is we're going to take each value that comes in and subtract the average, the mean of that value over the group. So it's going to be not the overall mean for the entire set, but per each group, which makes sense because remember, this is going to be sending the groups out to each node. So it's only going to have data available for that particular group. And what's coming in is a Pandas data frame, which is really a Spark data frame in this case. Now to make it easier so we don't have to keep prefixing our columns with PDF dot, we can just assign it to a shorter name V. So we're going to say V is really equal to PDF.V, which is coming in from our Pandas data frame. Very simple function. We're just going to say return PDF, our data frame, right? Assign. Now this is a Pandas function, assign. We're going to create a new column. We could replace an existing column as we'll see later, but we're going to just create a new column. I'm going to assign it a value equal to the V, this up here, right? V minus V.mean. So we're using the mean function. That mean is going to execute on the node and then come back with the mean for the group and then subtract that average or mean from V. To call that function, we're going to just use the group by off the data frame. So df.groupBy ID. And then we're going to extend that with apply in pandas. Now the apply in pandas is crucial because that's what allows us to call the subtract mean function we created. We have to tell it what's the schema of the values coming back. So the schema of the data frame coming back is right here. We have an ID, which is a long. We have the V variable, which is a double. We have our new column, V minus mean, which is also a double. And we'll put a show at the end so we can see how it worked. And it looks good. We ran it here. And notice we have, for instance, in our first group, we have two values under the ID 1. So 1 and 2. The average is pretty easy to calculate, right? 1.5. That's the average. So if we were to take 1.5 away from 1, we end up with a negative 0.5. If we take it away from 2, we end up with a positive 0.5. Same thing here now. We've got 2's, we've got 3, 5, and 10. And so subtracting the average of those away, we get this result. So it looks good. We got what we needed to have done there. So to give you a better example of how you actually might use this function, I decided to do something which I think is fairly common in machine learning, which is trying to normalize values. What's the idea of normalizing a value? Well, imagine you have something, especially say in sales. You could have sales which vary from $1 to $1 million. It was a huge range. And you can have values which vary that much. But you could also have something like age, which values tend to be probably from 18 to maybe 90 on most cases, the rest being sort of outliers. So a very narrow set of values in that. How would we include both of these in a machine learning model training without having the sales amount really skew the interpretation of the model? In other words, probably be overweighting those differences versus the age differences, which we don't really want. And this happens in many types of situations. In healthcare, you've got all different kinds of metrics related to a person's health, and you want them to be considered fairly consistently across, not overweighting one versus the other. So there are various methods that you can use to convert those values into something that's more consistent. In other words, limit the range to a consistent range across them all. One way to do that is to use something called the z-score. You can see in this picture here the distribution of our values over a normal curve. So we've got our mean in the middle, and then we can see the number of standard deviations away from the mean each value falls. we can see that 99.7% of the data will fall within 3 standard deviations of the mean. If it goes much beyond that, we could filter those out if they're outliers or figure out what to do. But the main point is, if we take values, whatever they are, and convert them to the z-score, which is what those numbers represent, the -3 up to the +3, then it doesn't really matter what we put into our model training. There'll be a consistent valuing system that mitigates the range differences and the way the different metrics are measured. So as complex as that may have sounded, it's actually really easy. Here we're going to define our function. We're going to get_z_score, passing in a Pandas or Spark data frame. We're going to take the PDF sales amount. We'll just call it sales amount to make it a little bit simpler. And we're going to do what we did before, PDF.assign. We're going to create a new column called z-score sales. And then we have a formula. We're going to do this part first, which we already saw, which is taking the amount, sales amount, subtracting from that the mean of this group from the sales amount, and then take the result of that and divide it by the standard deviation. And that gives us the z-score. So we can compare that to see if it looks reasonable. We'll also create a column called average sales so we can take a look at what the mean per group actually is. Now we can call it using the SPDF sales data frame that we created earlier. We're going to use the group by customer key in this case because we're going to be doing this z-score sales calculation by each customer. And imagine we could have many sales per a single customer, especially in a large company. We need to use the apply in Pandas as we did before. We call our function and we define our schema right here. We've got our customer key coming in, which is a long, the sales amount is a double, the z-score is a double, and average sales is also a double. So let's look at our results. We can see our customer key being displayed. We have 3 rows in the first customer, which is 11,000 is the number. We can see the various sales amounts here, which is the original value we passed in. And then we can see our z-score. And we can see we are in fact getting back what we expected, which is values between -3 and 3. Now let's talk about another function type we can do called map. From what I can see, this isn't stated explicitly in the documentation, but map seems to be primarily used to filter Spark data frame. So here we use the map in Pandas data frame function to transform, and here's another key thing, we're using an iterator of data frame, not a data frame. So there's a little bit of a difference. Iterators are vectorized, so it should perform better. So this will return the result as a PySpark data frame. The underlying function takes and outputs an iterator of Pandas data frame, and it can return an output of varying length, which makes sense. If you're filtering, you may pass in 1,000 rows, but you shouldn't necessarily be getting back 1,000. You may get something less. Let's take a look at the actual example. The simple example is data frame DF being created. We've only got 2 rows, a key of 1, value of 21, a key of 2, and a value of 30, which represents the ID and an age. You can see our function here, filter_func, passing in the Pandas iterator. And then we start our iteration here for PDF in iterator, yield, and then just PDF, the Pandas data frame, where the PDF.id is equal to 1. And then this calls our function df.map in Pandas, passing in our function name, and defining the schema as, using kind of a handy trick, we can take the input data frame df and attach .schema to use the schema property, and that will substitute in for the return schema. And it looks like it worked because we got just this row back, as we can see here. So it worked as a filter. Now I'd like to try a more complex example, and honestly I don't know if this is considered really acceptable to do. There's no real documentation around what you should and should not do in these functions. But the fact that we're using an iterator gives us an opportunity to do some work before we kick in the iterator itself. So what I want to do is broadcast a variable and then pick up that variable in my function and see if we can do that before the iterator kicks off. So sc broadcast 2. I'm just going to broadcast the value of 2. And I'm going to call that b_multiplier. And to make sure it worked, I'll display it here so we can see that we got that done. And there it is. We were able to retrieve it. Great. So let's take a look at how this works. We'll start very simply. We're going to create our data frame, create data frame as we did before. Identical, except I've added 1 extra row here so that we can kind of see better what's happening. And this is something where we can do some initialization work. As I mentioned, it may or may not be a good idea, but you can try it. It does work, at least in my example. Here I'm going to be pulling in the broadcast value, b_multiplier.value. and I'm going to store it in variable multiplier. Then I start my iteration of my Pandas data frame, and I say yield, and as before I'm doing a filter where the ID is equal to 1, and I'm doing an assign, and I'm creating a new column, age times x, which is equal to the pdf.age, but then I filter that on equal 1, and I multiply that by the multiplier, which is really coming from a broadcast variable. To call this, I use the data frame map in Pandas method, pass in my function, and define my schema. And it looks like it worked great because we can see 21 times 2 is 42, times 15 is 30, and we're not seeing the row that has an ID of 2, so it looks like it worked well. Kind of to reverse back, keeping it simple, but showing you something using a real data frame, in this case our SPDF sales. I'm just going to do the same thing we did in the simple use case, but filter on the customer key. And we'll say where it's equal to 11,000. Nothing else is really different other than that. And you can see we indeed get just those 3 rows. I couldn't help experimenting a little more here, so I want to do another example of map doing a calculation on a column in the data frame. So I'm putting here a little disclaimer. It may not be a good idea because I'm replacing the sales amount column with the z-score. And then I'm going to return this only where the customer key is equal to 11,000. And then we can call it here as we did earlier, so nothing really surprising here. So the takeaway is we're replacing the sales amount with a calculation which gives us the z-score. So it looks like it worked, and notice that this is how we were able to pass the schema in. We didn't have to change the schema going out from the schema in, so we were able to leverage the existing data frame schema to make the call. Now let's look at co-grouped map. The purpose of co-group mapped is to join data frames on specific keys. You've got 2 different data frames or more, and you need to join them at scale. The key thing to bear in mind is this can be a very expensive function because it's going to cause a shuffle. Shuffle is when the data on your cluster has to be rearranged. So what it's going to do is co-locate the data on every node so that whatever it's joining on is already there. It's together. So that's going to be a grouping operation that can take a little bit of time. All the data in a co-group will be loaded into memory. So beware that all the data for each co-group, i.e. what you're joining on, is going to end up being on each node. And if it's a really large data set, imagine you have very skewed data where you have 1 trillion rows of a specific group, you'll overload that node and crash your cluster. So you do have to be careful of that. This is just a note about another way to format this, and please see the documentation if you want to try a different way to code this particular example. So this consists of the following steps. Shuffle the data such that the groups of each data frame which share a key are grouped together. That's the idea. Get it co-located on each node. Apply a function to each co-group. In other words, this is the joining operation. Combine the data frames from all groups into a new Spark data frame. Here's our code example here. We start by creating our first data frame, df1, using the Spark create data frame method. And you can see we're just inserting, looks like 4 rows here, consisting of a time, an identifier ID, and a variable v1. So that's our first data frame. We're going to be joining that to df2, again creating this data frame. Same key values, so we have a time, an ID, and v2. And notice that the difference here between them is they've got the same keys, but the difference is v1 is this decimal number, and the second data frame, v2, is a text column. Also notice that we only have 2 values in our target data frame we're joining to, whereas we've got 4 rows on the source side here. So what that means is, what do we get here? Well, it turns out, as we'll see, this will be replicated as needed to make it match up basically to the other 4. So we'll actually get 4 rows. We have a function here that's going to do the join, left and right, and here's our function itself. Notice we're using the Pandas Merge as of function. So this is just a standard Pandas function. Here's our left data frame going in, and our right data frame. We're joining it on time, right, our time column, which would be like right here. We're also going to be joining it though by ID, which is this value. So we're actually using 2 different columns to do the join. The on gives us 1 and the by is giving us the second column. We start with data frame 1, we use group by, then we append the co-group with df2 and a group by same column ID, so that's how it's going to be grouping the data, and then call apply in pandas. Then we call our as of join function, which we created up here, and here we define our output schema. That's about it. That's pretty straightforward. In our output schema, we have the two key values here, the v1 from the first data frame and the v2 from the second data frame. You can see the output here. So here's our individual rows. You can see the first instance comes up with our 1, the 3, etc. coming from the first data frame, and then our x and y's as they joined too. So we get one consolidated joined output. If you want more information about the merge as of, as I said, that's a Pandas standard function. You can follow this link and that will take you to more information about that. I found it kind of interesting just to see what else you can do with that. Let's do a more practical use case. We're going to join two real data frames. We've already got a sales data frame, so let's create a customer data frame and then join the two together. So again, we're going to be using AW project. We're going to select customer key and birth date from dim customer, and we're going to store that result in SPDF customer. Okay, pretty simple. We've got customer key and birth date. Now let's run our as of join. This is even simpler than the last example. We have our as of join here, left and right, L and R coming in. Return PD merge as of. We're just going to be joining on customer key, so we don't need the by argument. We're just going to say on equal customer key. To execute that, we're going to call our SPDF customer data frame group by method, passing in the customer key, then calling the co-group with the SPDF sales group by customer key. From there, we're going to call apply in pandas, and then our function as of join. And here we define our schema, which will be coming back, which is our customer key, sales amount, and birth date, with the sales amount coming from our first data frame and the birth date coming from our customer data frame. Here's our results. Again, we got our customer key, sales amount, and birth date. We can see each customer key here, the sales amount, and the customer's birth date. So we successfully were able to join the two data frames. So in this video, we've learned about how to code the Pandas API functions. These are custom functions that you need to perform work at scale on your cluster, meaning you are going to run your code in parallel over the cluster nodes. And we looked at the three types. Group map, which allows us to use the split, apply, combine pattern in our code. We looked at map, which really just lets us filter, but we were able to use the fact that it uses a Pandas iterator to insert some code above it and do a little bit more. Whether that's advisable or not, I'm not sure at this point. I couldn't find any documentation to say whether it is or not. We also saw co-group map, which allows us to join two data frames. So please like, share, subscribe. I appreciate watching. Share my channel with other people and leave comments because I love to read the comments and reply to them. And until next time, I'm pulling for you. We're all in this together.